Quantum AI just did something classical computers struggled to achieve, and it could change the race for artificial intelligence. The quantum AI breakthrough that has researchers asking a bigger question about the future of computing. Artificial intelligence and quantum computing are two of the most talked about technologies on Earth, but they have largely advanced along separate tracks. AI has exploded into public life through chatbots, image generation, automation, and predictive systems, while quantum computing has remained a highly specialized scientific field, still searching for its defining commercial breakthrough. That is why reports of researchers successfully training an AI system using an IBM quantum computer have attracted significant interest. The experiment reportedly produced results that conventional systems struggled to match in the same scenario, immediately raising questions about whether quantum machine learning is beginning to move from theory toward practical reality. The real significance is not the result itself. The most important aspect of the story is not necessarily the specific benchmark or outcome. Scientific history is filled with impressive demonstrations that never became practical products. The bigger issue is what the experiment represents. For decades, researchers have believed that quantum computers might eventually help solve certain classes of problems faster or more efficiently than traditional machines. The challenge has always been proving that advantage in real-world applications rather than laboratory demonstrations. If quantum systems can genuinely contribute to AI training, optimization, pattern recognition, or complex decision-making, the implications could be enormous. Artificial intelligence currently depends on vast amounts of computing power. Training advanced models requires enormous infrastructure, huge energy consumption, and increasingly expensive hardware. Any technology that offers a fundamentally different approach immediately becomes strategically important. A potential shift in the AI arms race. The global AI race is often framed as a battle for bigger models, larger data centers, and more powerful graphics processors. Quantum computing introduces an entirely different possibility. Instead of simply scaling existing systems, researchers are exploring whether certain computational tasks can be approached through quantum mechanics itself. Quantum computers process information differently from classical computers, allowing them to explore complex mathematical spaces in ways that conventional machines cannot easily replicate. That does not mean quantum computers are about to replace today's AI infrastructure. Far from it. Current quantum systems remain limited, expensive, and highly experimental. However, breakthroughs often begin with narrow successes before expanding into broader applications. History shows that transformative technologies rarely look revolutionary at the start. Early internet systems appeared niche. Early smartphones seemed unnecessary to many observers. The first AI breakthroughs often appeared academic, before eventually reshaping industries. The scientific community is being careful. One reason this story is attracting serious attention rather than immediate hype is that researchers generally understand the dangers of overstating quantum breakthroughs. Quantum computing has endured years of exaggerated promises. Claims of imminent quantum revolutions have often collided with the reality of difficult engineering challenges and limited practical applications. As a result, many scientists now approach new announcements with caution. The reported success does not prove that quantum AI has arrived. It does not mean artificial general intelligence is around the corner. It does not mean conventional computing is obsolete. What it does suggest is that researchers may be identifying specific areas where quantum systems can contribute meaningful value. Even limited advantages could become important if they help improve efficiency, accuracy, or performance in specialized AI tasks. Why governments and technology companies care. The commercial implications help explain why so much money is flowing into quantum research worldwide. Artificial intelligence is increasingly viewed as a strategic technology capable of influencing economic growth, national competitiveness, defense capabilities, healthcare innovation, and scientific discovery. Quantum computing is often viewed through a similar lens. Combining the two creates a potentially powerful intersection. If future quantum systems can improve machine learning workflows, accelerate scientific modeling, optimize logistics networks, or enhance drug discovery, the commercial value could be measured in billions or even trillions of dollars over time. That possibility explains why major technology companies continue investing heavily despite the field's uncertainties. They are not betting on today's capabilities. They are betting on what becomes possible if current limitations are eventually overcome. The bigger question nobody can yet answer. The most fascinating aspect of this story is that it points toward a future that remains largely undefined. Nobody knows whether quantum machine learning will become a niche scientific tool or a foundational technology. Nobody knows whether the gains demonstrated in today's experiments will scale effectively into larger systems. Nobody knows whether entirely new forms of AI architecture could emerge from quantum computing research. What is becoming increasingly clear, however, is that the conversation is changing. For years, quantum AI largely existed as a theoretical possibility. Experiments like this push the discussion toward practical evidence. The breakthrough may ultimately prove modest. It may become a historical footnote, or it may be remembered as one of the early signs that the next chapter of artificial intelligence was beginning to emerge. That uncertainty is precisely why researchers, technology companies, investors, and governments are paying such close attention.